Dear student, Assalamu alaikum. I'm Dr. Muslim Khan, Assistant Professor, Department of Chemistry, CUST. Today, the topic of our discussion is chromatography. Course code is CAM 455, chromatographic and electrophoretic method of analysis. So, first of all, what is chromatography?
Is chromatography. The word chromatography is derived from the two Greek words, that is chroma means color and graphy to write. So basically this chromatography is a laboratory technique used to separate the different compounds in a mixture by mobile phase while passing through the stationary phase. This chromatography, literally color writing, was used and named in the first decade of the 20th century, primarily for the separation of plant pigments such as chlorophyll. So coming to the discuss the principle of chromatography. In chromatography, the solute particles you want to separate, the solute component you want to separate, partition itself between the two phases. Those two phases are, one is stationary phase and other one is mobile phase. As the name indicate, the stationary phase, the phase which is stationary at one place, and the mobile phase which is moving through this stationary phase. So this mobile phase refers to the mixture of substances to be separated, dissolved in a liquid or a gaseous. So that liquid or a gaseous phase is known as mobile phase, which is passing through the stationary phase. The stationary phase is a porous solid matrix through which sample contained in the mobile phase percolates. So interaction is developed of these different components of the mixture with mobile phase and stationary phase. So this interaction can be a physiological interaction, either adsorption, ion exchange, molecular sieving, or affinity, etc. So to discuss different types of chromatography, so chromatography have a different modes of classifications. So here we discuss two modes of classification. One mode is that how the stationary phase is held. So, and the other one is the interaction between sample component and stationary phase. So based on the interaction, or based on the how the stationary phase is held, chromatography have two types. One is this planar chromatography, other one is column chromatography. So based on the interaction between sample components and stationary phase, chromatography have different types like partition chromatography, adsorption chromatography, gel filtration, affinity, and ion exchange chromatography. So first we have to discuss uh, this uh, mm, this planar and column chromatography. So planar chromatography is a type of chromatography in which stationary phase is held in the form of plane, while column chromatography is a type of chromatography in which stationary phase is held in the form of column. So first of all, we have to discuss this planar chromatography and then column chromatography, and then we maybe later on these different types of chromatography, the second mode of chromatography. So planar chromatography have two types of chromatography. One is this paper chromatography, and other one is thin layer chromatography. So first we have to discuss this paper chromatography and then thin layer chromatography. What is paper chromatography? Basically, paper chromatography is analytical technique used for the separation of color compounds or those compounds which can be made colored later on. So this paper chromatography is can be used for the separation of amino acids, sugar derivatives, peptides, etc. And this paper chromatography have is like other chromatography have two phases. So this paper chromatography is also having two phases. One is this stationary phase. This piece of filter paper is used as a stationary phase, and other one is the mobile phase. Usually our student get confused that in a paper chromatography the stationary phase is a paper. No, The stationary phase is not a paper. Paper is just like a solid support. So the water inside this filter paper, inside this cellulose, inside those small pores. This paper is having a small pores. So in that pore, they have water particles. Those are acting as a stationary phase. So the mobile phase, this mobile phase is a mixture of immiscible solvent, which are mixture of water, non-polar solvent, and acid or base. For example, butanol, acetic acid water, or phenol water, ammonia system can be used as a mobile phase. So what is the procedure of a paper chromatography? So what is done? In the first step, on this piece of a paper, you just draw a line which is 1 or 2 centimeter away from the bottom of this paper. So then what is next? A small spot of this sample, which is having different component you want to separate, is applied to a strip of this chromatographic paper about 2 centimeter away from the bottom. This sample is absorbed onto the paper and may form interaction with it. This paper is then dipped in this mobile phase, but be careful. This paper shouldn't be dipped inside this mobile phase. Taking care that spot is above the surface of the solvent and placed in then this sealed container. So this solvent moves up. Here you see the solvent moves up through this paper by a capillary action. So once this solvent dissolve these different components, and these different components are going through the stationary phase along with mobile phase. So then, as I mentioned it before, these different components having a different interaction with the stationary phase as well as with this mobile phase. So different compounds in this mixture traveled at different rates. Here you see, like green line is here, yellow is here, and this pink is here, and this is here then. So this traveling of these different components depend on the solubility of the solvent, difference in the solubility in the solvent, and due to difference in their attraction towards the respective phases, like mobile phase and stationary phase. So this paper chromatography can take from several minutes to even several hours. So once you do this paper chromatography, so you get basically this kind of chromatogram. So this is a chromatogram. This is a paper chromatogram. So these different spots you see are different components of a mixture. So when this mobile phase is going through this stationary phase, the different components are basically separated from each other. So then you basically analyze this chromatogram. So after development, this chromatogram, the spots scoring corresponding to the different components, so may be located by their color, ultraviolet light, nanhydrines, or by treatment with iodine vapors. So this paper remaining after the experiment is known as this paper remaining after the experiment is known as chromatogram. So the compounds, these different compounds, these different colors, which are separated from each other, then you calculate the RF value for these different compounds. RF value for each compound is different. So what is this RF value? This RF value, this is the distance traveled by a sample component. Like for example, you want to do it for this, the distance traveled by a sample component from from initial point and divided by distance traveled by a solvent. So basically this is a ratio between the distance traveled by this component with respect to distance traveled by the solvent. How much this solvent goes from this bottom to here, like this is known as a solvent front. So if the RF value for any component is 0, what does it mean? It means that this component don't have any interaction with mobile phase, means it is not going with mobile phase. But if the RF value for any component is 1, it means that the solute don't have any interaction with the stationary phase. This is going with the mobile phase. So this RF value is a very important. Okay, so sometimes it is not possible to separate the compounds by a single run, just like this is a solvent and this is a drop of mixture and you want to separate the different components. So sometimes it is very difficult to separate the different compounds by a single run. So then what people do, like this is a kind of separation you get after one run. So people do second run but not in the same direction. People just change the directions after change the direction in a second run with a different solvent system, then you get this kind of separation from each other. So this is known as, so change the direction means you just change it at 90 angles, at right angle. So this is known as a two-dimensional chromatography. So the next one is thin layer chromatography. The thin layer chromatography is also a type of chromatography, is type of a planar chromatography. Is routinely used by the researcher in the field of phytochemicals, biochemistry, so forth, to identify different components in the mixture. So it is this thin layer chromatography is a semi-quantitative technique, and is a just like nowadays people use high performance thin layer chromatography. HPTLC is the more sophisticated or more precise quantitative version of this thin layer chromatography. So just like other chromatographic technique, this thin layer chromatographic technique is also having a two phases. One is stationary phase and other one is mobile phase. So this one, it contains the stationary phase of a thin layer of adsorbent material such as silica gel, aluminum oxide, cellulose, immobilized onto a flat inert carrier sheet. A liquid phase consisting a solution to be separated is dissolved in appropriate solvent and it is drawn up by the plate via capillary action. This thin layer chromatographic system is having a similar principle, that the compounds to be separated, the mixture having a different components is placed here, and then these different components are separated on the stationary phase while mobile phase is passing through it. This thin layer chromatographic system is having a different components. One is this TLC plates and other one is this TLC chamber, and the third one is the mobile phase. So this TLC plates, so preferably, like usually people are using this ready-made plates with a stationary phase. So these are basically stable and chemically inert plates where a thin layer of a stationary phase is applied onto its whole surface. The stationary phase on the plate is of a uniform thickness so that a uniform separation is achieved. So the next one is this TLC chamber. This is used for the development of a TLC plates. TLC, the chamber maintain a uniform environment inside it for the proper development of this chromatogram. It also prevents the evaporation of solvent. It keeps the process dust free. And the next one is this, the third component is the mobile phase. So this comprises of a solvent or a solvent mixture. So this mobile phase used should be particulate free and of the highest purity for the proper development of these TLC plates. The solvent recommended are chemically inert with the sample and stationary phase. So how these plates are basically prepared. So these plates are usually commercially available, like in the market, as I mentioned it earlier. So, or they may be prepared, they are prepared by mixing the adsorbent, just like silica gel, aluminum oxide, etc., adsorbent, with a small amount of inert binder, inert binder like calcium sulfate and water. The mixture is then spread on this. The mixture is then spread on a is a thick slurry on a unreactive carrier sheet, usually glass, thick aluminum foil, or even plastic can be used. The resultant plate is, these plates are dried and activated by heating an oven for 30 minutes at 110 degrees centigrade. The thickness of this plate, the thickness of these TLC plates is usually from zero point 0.1 to 0.25 millimeter for analytical purposes, and around and around 0.5 to 2 millimeter for preparative TLC. So what is the procedure of thin layer chromatography? So just like a paper chromatography and thin layer chromatography, first of all, the line is drawn here at the base of these TLC plates, and then a sample which is having a different component is applied on this line, and this plate is then placed in a TLC chamber which is having a mobile phase, and we discussed that what is the mobile phase. So then this mobile phase is going up in this TLC chamber on this TLC plate through a capillary action, and this mobile phase dissolve this sample which is having different components of the mixture along, and is taking along with it these different components having a different interaction with the mobile phase as well as the stationary phase on this plate. So on this principle, which is having a different interaction with the mobile phase and stationary phase, these different components are separated. You see the different colors here on these plates. So these different, and then the rest of the procedure. So you get this, basically you get this chromatogram. So then you calculate the RF value for each of component present on this TLC plate. RF value, you know what is RF value? RF for each component is the distance traveled by, the ratio of the distance traveled by each component with respect to the distance traveled by this mobile phase. So what are the advantages and application of TLC? First of all, it is a very simple process with a short development time. It helps with the visualization of the separated compound spots easily. This method is help to identify the individual compounds in the mixture. It helps in the isolating of the most of the compound. The separation process is faster, and the selectivity for compound is higher. Even with the small differences in chemistry is enough for clear separation. The purity standard of the given sample can be easily assessed by this chromatographic technique. It is a cheaper chromatographic techniques as well. Also to check the purity of given compounds, identification of compound like acids, alcohol, proteins, alkalides, amines, antibiotics, and more. Also, this technique is used to evaluate the reaction process, specifically for organic chemists, to evaluate the reaction process by assessment, the intermediate reaction course, and so forth. And to purify the sample, this is also used. To keep check on the performance of other separation processes, TLC is also used. So being a semi-quantitative technique, TLC is usually more for rapid qualitative measurement than for quantitative purposes. So it is not usually used for the quantitative purposes. It also finds its application as one of the most widely used chromatographic techniques in the organic chemistry.
So basically, there are different modes of classification of chromatography. The first one is on the basis of chromatographic bed shape. The chromatography have the bed shape of chromatography will either be two-dimensional, which will be having which is again further classified into thin layer chromatography and paper chromatography, and three-dimensional chromatography is having the bed shape is in the form of column. We have also discussed this in our previous lecture that This classification, you can call it that how the chromatography plane is basically held. The how the chromatographic plane is held. Either it can be held in the planar form, that is called planar chromatography. Planar chromatography is actually called a two-dimensional chromatography. This is again further having a 10-layer chromatography and paper chromatography. And we have discussed these two chromatography in details, 10-layer chromatography and paper chromatography. And the next one is three-dimensional chromatography, is also known as a column chromatography. The column chromatography we will discuss in our today lecture as well as in our future lecture, that what is a column chromatography. The next mode of classification is on the basis of solute interaction to the stationary phase. As we know that chromatography is having basically two phases. One is a mobile phase and other one is stationary phase. So basically in chromatography, we are mixing or analyte means or solute with mobile phase. Then this mobile phase is passed through the stationary phase. Then inside this mobile phase, we are having a solute, means the mixture, which is having different analyte. This solute having a different types of interaction with this stationary phase. So on the basis of this interaction, chromatography is further divided into partition chromatography, adsorption chromatography, gel filtration chromatography, affinity chromatography, and ion exchange chromatography. The next important mode of classification of chromatography is on the basis of physical states of a matter. Means you have two phases in chromatography. One is the stationary phase and other one is mobile phase. So if your stationary phase is, if your mobile phase is liquid, and your stationary phase is solid, then it is called liquid solid chromatography. It means that your mobile phase can either be liquid or gas. So if it is a liquid, then it is a liquid chromatography. If it is a gas, then it is a gas chromatography. So the similarly, mobile phase can't be solid. And so on the other hand, your stationary phase either can be liquid or solid. So stationary phase uh, can't be gas. So again, then if it is a solid, then it is liquid solid chromatography. If it is a liquid, then it is called liquid liquid chromatography. But this one we will discuss in detail in coming slides. So we are not discussing we are not discussing basically this planar and thin-layer chromatography, means paper. We have also already discussed in detail in the previous lecture. Based on the interaction between sample components, means those in the light component which we want to separate with stationary phase, chromatography is classified into partition chromatography, adsorption chromatography, gel filtration, affinity, and ion exchange. We will discuss these chromatography one by one in detail. First of all, what is partition chromatography? Basically, this form of chromatography is based on a thin film formed on the surface of a solid support by liquid stationary phase. So the principle of in this chromatography, the separation of the component from the sample mixture is carried out uh, by the process that the component partition themselves between the two phases basically. So solute equilibrates between the mobile phase and the stationary phase. So if this is your stationary phase, let's say this is, if this is your stationary phase, so in this chromatography separation method, where analyte, where you have analyte is contained within a liquid or gaseous mobile phase, is pumped through this stationary phase. So these different component in your mobile phase having a different interaction to this stationary phase as well as with your mobile phase. It means that the component in the mobile phase and
with this surface, they actually partition themselves between the two phases. So actually this usually one phase is hydrophilic and the other phase is lipophilic. Lipophilic. The component of the analyte interact differently with these two phases, with this hydrophilic and lipophilic phases. So depending on the polarity, they spend more or less time interacting with the stationary phase, are thus retarded to a greater or lesser extent on these two phases. So this leads to the separation of the different component present on the sample. So paper chromatography, as I mentioned it in our previous in my previous lecture, that usually students think that paper is basically a stationary phase. Paper is not a stationary phase. Inside the paper there are water particles. That is basically a stationary phase. So paper chromatography is one of the typical example of liquid chromatography, is the typical example of partition chromatography. So we have discussed it in detail. I don't want to discuss it here, but this was just a short introduction of partition chromatography. The next one is adsorption chromatography. Adsorption chromatography, we have also already discussed this in detail. This is one of the oldest type of chromatography around, this adsorption chromatography. It's in adsorption chromatography, it utilizes the mobile liquid or gaseous phase that is adsorbed on the surface of a stationary solid phase. So basically, the equilibration between the mobile and stationary phase accounts for the separation of different solutes, but this exercises the adsorption behavior of the stationary phase. The stationary phase used in adsorption chromatography is known as adsorbent. So this is basically based on the principle that some solid substances, which are known as adsorbent, have the power to hold molecule at their surface, because as I mentioned it, adsorption is a surface phenomenon. It's not like absorption. It is absorption, and this is a surface phenomena. So a different adsorbent have a power to hold molecule at their surface. And this holding is, why this holding is occurring? This holding is due to the weak non-ionic attractive forces of the van der Waal and hydrogen bonding, which only occurs at specific adsorption sites or beds. These adsorbent beds can differentiate between the organic molecule adsorbate based on their strength of a binding. So some molecule have a more strength, more interaction with this surface, this van der Waal forces, hydrogen bonding of some of the molecules are greater in nature, and some of the molecule are lesser in nature. So these differences in the strength of the compound leads to the separation on the adsorbent surface, basically. A solvent eluent mobile phase is constantly pumped through the adsorbent stationary phase in the column. Differences in the compound flow rate eventually leads to the separation of the organic mixture. The most commonly used adsorbents are silica, alumina, and carbon. And we have discussed also this in detail as well, because thin layer chromatography is one of the typical example of adsorption chromatography. So our next one is molecular exclusion chromatography. This is also called gel permeations or gel filtration chromatography, but it is not like the adsorption or partition chromatography, because in this chromatography, scientists have exercised not the interaction between your analyte and your stationary phase or mobile phase, but scientists have exercised the size of your analyte, because your different analytes have different size. So this type of chromatography lacks in interaction between the stationary and solutes. But on the other hand, the liquid or gaseous phase passes through a porous gel, which is having pores, which separate the molecule
according to its size, basically. The pores are normally small and exclude the larger solute molecule but allows smaller molecule to enter the gel, causing them to flow through the larger volume, basically. So in this technique, the separation of component is based on the difference in the molecular weight or size. So different pores. So these are large molecule, these are the small molecule. The stationary phase used is a in this stationary phase is a polymer matrix whose pores are completely filled with the solvent to be used as the mobile phase. The molecule and the sample are pumped through this specialized columns containing such microporous packing material, usually known as gel. That's why it's called gel permeation or gel. It is usually a kind of filtration, so that's why it's called a gel filtration chromatography. The basis of this separation is that molecule above certain size are totally excluded from the pores, while smaller molecule access the interior of the pores partly or wholly. The flow of the mobile phase, basically, the flow of the mobile phase hence will cause larger molecule to pass through the column unhindered without penetrating the gel matrix, whereas smaller molecule will be retarded according to their penetration of the gel. Uh, the component in this molecular exclusion chromatography are size gel filtrations. One is stationary phase, other one is mobile phase, and other one is the column which is having this gel, which is having this polymeric gel, and the pump which pumps mobile phase through the stationary phase, and the last one, the detector, which detect uh, the analyte component. Stationary phase is composed of semi-permeable. This is stationary phase composed of semi-permeable porous polymer gel beds with a well-defined range of rock of pore size. It is the following. This porous gel stationary phase having this must be chemically inert. Should not react with your analyte molecule. They should be mechanically stable. So with heating or with some other things, it should not change its behavior. With ideal and homogeneous porous structure, means uh, having a wide pore size, giving low resolution. A uniform particle and pore size is one of the key to this gel permeation chromatography. Example of gel maybe Cephadix, Dextron, agarose gels. These are some of the typical gel used in this gel permeation chromatography. Uh, Different columns are used: analytical column, preparative column, usual column, means narrow bore column. These are the different columns. Uh, this depends on the size of the beds. Like some of the column are 7 to 8 millimeter, some of the 25, 30, even 50, 60 centimeter long, and some are 2 to 3 millimeter diameter. And these are, and also pumps and detectors, different detectors are used in this chromatography. So this is one of the molecular exclusion, one of the type of chromatography. Uh, uh, so